Okay, we will be introducing today wind energy. We are Team B. My name is Erik Gutierrez.
I'm Guerra. I'm Edwin Moore. And starting us off, a little intro and background is Erik.
Okay, to begin with, we will be talking about wind turbines. These machines use wind to create electricity, and they were first established in the late 1800s to help pump water for irrigation and generate electricity. This was mostly in farms and basically in the Midwest of the United States. And that's when it started to take off. It was like a revolution until it took a hard decline in the 1950s due to disuse. And this disuse came from low gas prices, low interest rates, which allowed people to use other means to generate electricity. And it stayed like this for quite a bit of years until it boomed again in the 1970s. And this was again due to high gas prices, high interest rates, and alertness of the ozone damage that was created due to these emissions. And this booming, it started a revolution pretty much, and it reached an all-time high in 2007 when it accounted for 5% of the US renewable energy. I will be now introducing the pros and the cons. The pros of this is pretty much that it is worth the money invested. To begin with, to start one of these up, it is a pretty costly investment, but throughout time, it will be well worth what was invested, part in fact because the energy being produced is compensating for that initial pricey beginning. Also, it is non-polluting, and by this I mean there is no emissions, and therefore it is eco-friendly, and the ozone is being protected or not harmed. Also, it is a renewable source of energy. What this means is that the sources that are being used by this wind turbine are not being affected. So in the future, the same amount of sources will still be available to power it. A free resource. By free resource, I mean that wind is powering these, so there will be no cost to power them. It will always be there, and again, it is free and clean. Cons. Like I said before, it is a pricey initial cost. So that can be a downside to most projects and designs. A danger to the avian pollution. This is for all the animal lovers and stuff. It can be a very big downside to that because these turbines don't stop. And therefore birds, bats, any flying species is flying in there and, well, they're pretty much dying. And again, because it does rely on wind, that can be a downside because it does not keep going. Since wind fluctuates, it's going to need constant wind, which it does not have. Next, it will be Edwin introducing how these machines work.
This is an example of an upwind horizontal axis wind turbine. The whole thing is mounted on top of a tower. At the top of the tower, there's a yaw motor which controls the yaw drive, which helps orient the turbine into the wind. The top of the tower is in the cell that contains or has mounted to every other part of the turbine. At the front are the blades, which are mounted to a rotor and will rotate with the wind. The rotor has two different systems that help keep it going. There's a pitch system which will help keep it straightened into the wind or turn it out of the wind if the wind's blowing too hard. There's also a brake in case of emergency that is usually hydraulic, electric, or mechanical. From there, the rotor is connected to a low-speed shaft that spins at about 30 to 60 RPMs. The low-speed shaft is controlled by a gearbox. The gearbox is a heavy and expensive piece of machinery that engineers are currently trying to eliminate from these designs, but it does increase the speed in the high-speed rotor so that it can be fast enough to generate electricity between 1,000 and 1,800 RPMs. Inside the generator, The electrical current is produced, it's an AC current, and from there it is fed down to the electrical grid. The whole thing is controlled by a controller box. The controller box will sense when the wind is up to 16 miles per hour, which is when the blades will start to turn, and it'll shut it off if it gets above 55 miles per hour, because that can be damaging to the turbine. From there, outside the nacelle is mounted a wind vane. The wind vane will help the yaw drive keep it oriented with the wind, and the anemometer will feed information back to the controller, which will let it know just how fast the wind is blowing. Here's an example of a small wind turbine, usually used for dairy farms and for small rural villages. These are upwind turbines, and they don't require all the steering mechanisms. They just need a wind vane to help keep them oriented towards the wind. This is a larger wind turbine. It is probably a downwind turbine where the wind blows from the back side of the tower and brushes over the blades from the rear. This allows the turbine to always be facing the right direction with the wind, because the wind basically controls the steering of it. These are the two main examples of wind turbines now. This is the old system that we've had around for a while. It's the horizontal axis turbine, and it is called that because of the rotor being in a horizontal position in the turbine. This is the vertical axis turbine. It's a relatively new technology. The rotor is this vertical piece here. With the horizontal one, if anything breaks in here, you have to climb up to 10 meters to get it fixed. And that's in windy conditions. So any mistakes and you could have a bad day. Here, everything is on the ground. Anytime you need to fix anything, if the gearbox goes wrong, the generator goes wrong, it's right there at ground level to fix. So you're not up high or in the wind having to fix it. Also with the vertical turbines, they're an omnidirectional turbine, which means the wind can blow from any direction and it will still function. So it doesn't require all the steering mechanisms that the horizontal one does to function properly, as well as it'll actually work very well in low wind speed conditions. Our offshore wind turbines are the largest ones we have. They do about 2.5 megawatts worth of electricity. They're currently working on doing vertical axis wind turbines offshore to eliminate the problem of everything being mounted high up where they have a hard time getting it to fix, and instead put it down here where you don't have to land a helicopter on top of the nacelle to fix it. Instead, you can just come right up to it, get out, and do your business. Up next is Chris to talk to you about the wind industry.
So with all these technological advancements, the U.S. has actually jumped to #1 in the world in wind energy production and #2 in wind energy capacity, second behind China. Now the difference between wind energy production and wind energy capacity is that production is how much electricity is actually being produced and fed into the grid, while capacity is just a measure of the amount of infrastructure that is capable of producing energy. Now the reason we're #1 in production ahead of China, even though they have more wind turbines than we do, is that we take advantage of better climate and we have much better technology than they do. Now, over the last decade or so, we have jumped from around 5,000 megawatts in capacity to roughly 60,000 megawatts, and our top producing states are going to be Texas, California, and Iowa. Now, this rapid growth can be attributed to government policies, one of which is the Renewable Energy Standard, which is a state-level law that requires a certain amount of energy to be produced by renewable sources such as wind. And then also there's the production tax credit, which is a federal tax incentive which rewards 2.1 cents per kilowatt hour produced by wind energy. Now this is a time lapse of the growth of wind farms across the U.S. I just want to point out Texas, California, and Iowa are going to be dark green over the years, and a lot of development will occur in the Midwest here along with this region. Now this is what it looks like today with Texas having around 13,000 megawatts of our 60,000 in capacity. Now this is a graph showing how much potential wind and strong wind speeds across the nation. As you can see, the Midwest is a very, very windy region, along with steady winds across the western coast. Now this is a similar graph, but this highlights the coastal winds, and as you can see, there's a lot of opportunity to harness wind energy all along the coastlines. And as Edwin mentioned, that the largest wind turbines we have are actually offshore. With that being said, in a perfect world, we would be able to produce maybe 10 times the amount of electricity that we consumed this past year just off of wind alone, but it's not really realistic to harness every single ounce of wind energy. However, the US government has set a goal in place to have 20% of our electricity to be produced by 2030, and at this rate, we are going to meet that goal. Right now, we are only around 4%, but 20% is in the near future, and if we hit that mark, we will be a much cleaner society.